Okay, so we're going to prove that for any complex numbers z1 and z2, that the conjugate of z1 plus or minus z2 is equal to the conjugate of z1 plus or minus the conjugate of z2. So let's go ahead and start this proof. Okay, so since z1 and z2 are complex numbers, let's go ahead and write let z1 be equal to a sub 1 plus b sub 1I. And of course, where a1 and b1 are real numbers. And we'll let z2 be equal to a2 plus b2I, where a2 and b2 are real numbers, right? Okay, so we want to know what z1 conjugate and z2 conjugate are. So let's go ahead and write those out. So we know that z1 conjugate is going to be a1 minus b1I, and z2 conjugate is going to be a2 minus b2I. Okay, so now let's go ahead and observe what z1 plus z2 conjugate is going to be, right? So we know we'll have z1 plus z2 conjugate. This is going to be equal to, so z1 is a1 plus b1I, and this will be plus a2 plus b2I, and this will be all under that conjugate, right? And this is equal to, so we can put all the real stuff together and all the imaginary stuff together. So this will be a1 plus a2 plus b1 plus b2I. So we'll make sure to factor out the I from both of these, because when we have it in this form, we know the conjugate of this is just a1 plus a2 minus b1 plus b2I, right? Since real numbers are closed under addition, this is just a real number and a real number. Since it's of that form, we know the conjugate of this is going to be this. Now, we have a1 minus b1I, right? Plus a2 minus b2I, right? Because minus b2 and then b2 times I would be negative b2I. Same thing for b1, right? Negative b1 and then I. And of course, this is our z1 conjugate, and this is our z2 conjugate. So we've proven that the conjugate of z1 plus z2 is in fact equal to the conjugate of z1 plus the conjugate of z2. Okay, so let's go ahead and move on to the difference one. So let's look at z1 minus z2, the conjugate of that. So this is going to be equal to, so z1 is a1 plus b1I minus a2 plus b2I, the conjugate of that. This is equal to, so this will be a1 minus a2, right? And then this will be plus b1 minus b2I, right? This will be positive b1, and this will be minus b2, and then we can factor out the I from both of them. Okay. Now we know the conjugate of this, since subtraction is closed for the reals, right? We know both of these are real numbers as well. We know that this is going to be a1 minus a2 minus b1 minus b2I, right, for the conjugate. Okay, so this is going to be equal to, so this will be a1, let's see, so negative b1I, so minus b1I. And then this one is a little tricky. So we'll do minus. So if we do minus, this will be a2, right? Because negative a2, if we distribute that negative. And this is negative b2i, right? So we can have a minus b2i here because this would be positive, right? But if we factor out the negative, then we need this times this to be a positive. So this is the same thing as this, right? And then, of course, this is equal to z1 conjugate minus z2 conjugate. So we've proven that the conjugate of z1 minus z2 is in fact equal to the conjugate of z1 minus the conjugate of z2. Okay? So we've proven both of these statements that we wish to do. So we've shown, so therefore, right, z1 plus or minus z2, the conjugate of that, is in fact equal to z1 conjugate plus or minus z2 conjugate. And that is the proof.